Hello and welcome back. It's Arrays of Strings, lesson 205. So basically the idea here is that we want to extend everything we know about primitives in an array, primitives being an int or a double or a char, and we want to dive into the world of objects. As a good stepping stone into the world of objects, we should take a look at strings. So for strings, much like you do with an int, you write the word string in front of the brackets, and that lets Java know that you're trying to construct an array, the brackets, of type string. We give a reference variable. You can either make that a standalone statement, or you can build that in with the equals new string bracket 8, meaning I want 8 spots. What this does is, just like it does with an int, it creates 8 locations that you can store strings in. So I could say strarray bracket 0 equals hello. I'm storing the string hello in slot 0. The big change that you have to be careful of when you take this advanced step up into strings as opposed to primitives is that now you have to be a lot more suspect of null. Null can cause a whole lot of problems both in the array statement or in the slots. So you have to be very mindful of that when working with the code to avoid null pointer exceptions. So when I first make strarray, it's null. It itself is null because it doesn't point to anything. Once I make the instantiation statement and I actually construct it, then it points to 8 slots. Each slot has null in it. If I try and access any slot of the array at this step, I'm going to get a null pointer exception. Once I populate it with hello, this pointer then points to the slot of memory, that then points to the word. So we start to create this like web of different things pointing to different information. The real catch is, before you do anything with this array of strings, you really should be looking for null. All right, so let's take a look at it. So here we have a search method. It's going to take in an array parameter. It's then going to have a target word that it's looking for. What's nice about working with strings, it helps you avoid that common pitfall of confusing the position with the value. Numbers have a bad habit of tricking us into thinking that we're grabbing the number when we're really grabbing the value, or the value when we want the number. For strings, it's a little bit easier to tell the difference because one's a word and one's a number. So this is actually the word we are looking for. And again, Java knows this is an array because of the brackets. So I create a for loop from 0 up to the array.length. I want to look at every spot in the array. Now this method does not know whether or not the array is full, or maybe the array only has 3 words in it. I don't really know the state of the array. I did not have any kind of a precondition telling me that in advance. I'm just going to handle any kind of array. That's the nice kind of broad aspect of working with methods. Loop through the whole array if array bracket j dot equals target. I need a dot equals here because strings are not primitives. Primitives use equals equals, but everybody else, strings or any other advanced objects, use a dot equals. It's already built into the string. I don't have to write it, but I have to use the dot equals because strings are types of objects. If my array equals my target, I'm going to return j, which would signify success. Return ends the whole method. If this if was never triggered, I'm going to return -1. That's going to signify that it was not successful. This code will compile fine. When I go to run it, if my array is full, this code will work beautifully. If my array has any gaps in it at all, whether at the end or at the front or the middle, anywhere you want, I'm going to run into problems. So what I really should do, I'm going to open this up on IDE 1. Here you can actually see that I've got a tester, I've got a main, I've got my new string, bunch of towns. I'm going to do a search, and it's going to say whether or not it's successful. Remember, because search is going to return an integer, and that is the slot that it occurred in. I'm going to assume that I'm working with other computer science folks, and then I can return its actual slot. If you're trying to work with end users and they don't understand that we start counting at 0, you can fudge this a little bit by just saying +1 to have it make a little bit more sense to the casual user. I'm going to search there. So that's the whole idea. I'm going to come down here and I'm going to tweak this just a little bit. And I'm going to say if array bracket, oops, that's a J, does not equal null. I want to put a null check in there to verify that it's not null before I start checking for equality. If I try and feed a null into a dot equals, the program's going to crash. So I want to check for null first. So I'm going to say if it's not null, and, then I can do my check. The nice part here is I'm using short circuit. So if it is null, it fails and it never gets to that second case. So now my code will work nicely. So this will work a little bit better for an array that's got a few gaps in it. And then life is good. So if I come back over here, give us a little shift. All right, so here's a funkier example, and I picked this one up just to point out a couple different things. First off, note the fact that Java's ironically kind of forgiving in how you set up the brackets. Many things in Java, it's very particular about where you put them, but other things, it kind of gives you a little bit of slack. If you want, you can say string cats bracket bracket. So the brackets can either go after the type or they can go after the variable. Java accepts either way. My guess is it's a little bit more compliant with other languages to make it a little bit easier if people transition over to Java. It's my theory as to why it does that. So I've got this array of strings, which are all of my previously owned cats. So they're all in this array, and then I'm doing something kind of cool down here. I'm using a for each loop. A for each loop is new in Java 5. It allows you to access all the contents of an array without having to manage position. Now it's very important to note that if you want to talk about the position, if you're searching for something and you want to report where it's at, a regular for loop is the better way to go. But if you just want to look at the data inside an array, particularly of objects or of strings, it's kind of nice to use this for each loop. That way you don't have to worry about position at all. It makes it a little cleaner. It makes it less likely that you run into bounds issues. So I'm going to have string kitty, which is just a temporary variable that I'm making up, string kitty colon cats. What this is going to do is kitty will take on each word inside cats one at a time. So first kitty will be link, and it will stay link for the whole first run of the loop. On the next round of the loop, kitty will now be the word Zelda, and it'll stay that for a whole round of the loop. On the next run of the loop, kitty will be Wesley, and we'll just cycle through and look at each cat one at a time. So what this is essentially going to do is it's going to print out hello Link, hello Zelda, hello Wesley, hello Buttercup, and it'll list them all in a row. So if you're in a situation where you have an array of objects, strings or more complicated objects, a for each loop might be a nice way to access them. Technically though, you could do it with an array of primitives, should you want. Just keep in mind that you look at the value, you do not get any access to the position, and it's not really the best place to change things. It's more of a looking loop than a changing loop. So depending on what you're doing, it might make your code cleaner. It will show up on multiple choice questions on AP, and it will show up on the free response. So it's a good thing to be familiar with, even if you don't choose to use it yourself all that often. All right, so let's talk about manipulating. So here we have an interesting array holding Han Solo, Null, Secret Ninja, AP Test, and Hunter Central. I'm then going to take this method, first names, and I'm going to pass this array of names into it. So it's down here, we're local, so I don't need any dot out front, so it's an immediate call, and I'm getting name list. Name list, I use a for loop, a traditional for loop, and I'm going to ask if it's not null, then I want to do stuff. So that's going to help me avoid this null in the middle. This little if statement's a really good one to have anytime you're working with an array of strings or objects. You really just want to safeguard yourself. So what am I going to do? I'm going to take that slot of the array. I'm going to do a substring on it from 0 up to namelist.index of space. So essentially what that's going to let me do is I'm going to take this two-word statement like Han Solo. I'm going to go up to where that space is, and I want a substring from 0, which is where the H is, up to but not including the space. So it's essentially going to grab me the first name. I'm then going to put a space, and I'm going to accumulate that all into out. So this is going to loop through this array and grab me the first names of every non-null. So I'm going to get Han, Secret, AP, Hunterton. And that's going to be my output. All right, so this is kind of a fun one. As we go through AP, we start to realize that this public static void main business that we've been writing on every single code actually has some meaning. And you can actually start to piece together what some of these words mean. We talked back in chapter 1 about the word public, so that means it's universal, everybody can see it. Back in chapter 1, we also talked about static, meaning there's only one copy of main that everybody shares. Today we're going to talk about what's in this parenthesis. What's in this parenthesis is actually a parameter to the main method. The string bracket bracket is signifying that you're talking about an array of strings. This word arguments is actually not mandatory in Java. We use it more as a matter of convention. You could write any word you want here and Java will still compile absolutely fine. You could say string bracket bracket pirates and it will still work absolutely okay because this is just a reference to what you're calling this array of strings. This array of strings is fed to you when you compile your program. In JCreator, we have a nice button to compile, so you kind of forget what's actually happening. If you worked on a command line console and you actually did Java C space your program, then it's a little bit more tangible that you're compiling it. It's actually an execution code to your computer. If you're familiar with DOS or Linux, then you're used to the idea that sometimes when you do a line on the command line, you could put a space and add extra things after it, like a -ls. Those extra things afterwards are commands that your program will need to run. So technically, if you wanted to, upon execution of the program, you could feed it data at runtime. You could feed it locations of input files, you could feed it locations of output files, you could feed it usernames, you could feed it anything you want. You could actually give it to it at execution time. Here we see directions for how to play around with that in JCreator. You can do it in JCreator, it's just a little bit more cumbersome to be able to get in there. For the purposes of our course and for the purposes of AP, you never have to reference these. I do know that some students have told me that when they went on to college, it was standard issue that the two parameters for every run program would be the input file and the output file. That's the way their school ran it. I've also done some programming competitions where they have that be the same information. One parameter is the input, one parameter is the output. So it's a nice thing to be aware of even if we don't regularly use it. All right, enjoy the lab.